Good day once again, class. So this is just a continuation of our topic on problem-solving strategies. So last presentations, we were talking about the four steps process introduced to us by Paul Yates. And for this time, we just continue with the other examples of problems. So we have here problem number 6. It says that 9 athletes from a track and field team stop for a lunch. The men eat 4 pieces of pizza each, the women eat 2 pieces each, and the coach eats 3 pieces of pizza. If the team bought 4 pizzas, each cut into 8 pieces, and there were 5 pieces left over, how many men and women were on the team? What we know so far, class, is that there are 9 athletes. These are combinations of men and women athletes, not to include the coach. So we are not concerned, class, of the gender of the coach, whether a man or a woman, because we are only asked how many are men athletes, how many are women athletes. So in understanding the problem, we can identify the given data. So there is a total of 9 athletes plus one coach. The men can eat 4 pieces of pizza, while women can eat 2 pieces of pizza. Now, because there is a total number of 4 pizzas class with 8 pieces, slices, per pizza with 5 left over. So we can actually see already here that when you multiply 4 times 8, we have a total of 32 slices. And we can, of course, have an idea already on how we are going to solve our problem. So when we devise a plan to solve the problem, class, so you can have many ways of understanding or solving this one, but the best now so far is to use listing and by trial and error. You can also use, class, the concept of algebra or algebraic solutions here. So this will be our plan, is to use a trial and error with listing of your trials and errors. So first, we know that each athlete, a man athlete, can consume 4 pieces of pizza, while a woman athlete can consume 2 pieces of pizza. Of course, the coach, according to the problem, can consume 3 pieces of pizza. So, if you're going now to have, there is a total of 27 all in all. Okay. So, in this case, there will be 5 left over. So, how did we know that there will be 27 all in all? Remember, class, that each pizza has 8 pieces or 8 slices, and they have 4 pizzas. So, 4 times 8 is 32, and of these, 5 are left over. So, 32 minus 5 is 27. So, they only consume plus 27 all in all. Okay, with the 5 left over. So, what we do is, of course, if there is only one man as an athlete, but he consumes 4 pieces, then there are 8 women who consume 2 pieces each. And of course, the only coach that consumes 3 pieces. So if you're going now to multiply the number of pieces of pizza that these people or athletes, including the coach, can consume, so 1 times 4 plus 8 times 2 plus 1 times 3, so a total of 23. So there is only a total of 23 pizzas if we have 1 man, 8 women, and 1 coach. But it should be equals to 27. Then, another trial and error. So we list again. What about if we have 2 men athletes and 7 women athletes? So you know that the sum still equals to 9. Then there is only one coach. So 2 times 4 plus 7 times 2 plus 3, then the total again is 25. So since it should be equals to 27, it means that these combinations of men athletes and women athletes is not the correct answer. Then we can increase again. We can have 3 men athletes and 6 women athletes. So if we continue that, if there are 3 men who can consume 4 pieces, that's 3 times 4, and 6 women who can consume 2 pieces, that's 6 times 2, and of course the coach, there's only one coach who can consume 3 pieces. So if we are going to multiply and add, then this gives us already a total of 27. And because there are 5 left over, so 27 plus 5 is 32, which is now the total number of slices of the pizzas. And therefore, we were able now to identify our solution. That 27 all slices of pizzas being consumed because 5 were leftovers, and this gives us now that there are only 3 men and 6 women athletes as our final solution. Okay, and as I said, because this is by trial and error, so using such technique class is already checking for itself. Now, an alternative solution for this one class, as I said, is you can have your algebraic solution. So we can again solve the same problem using algebra. So you let your x be the number of men, while y will be the number of women. And we know that when we add x and y, it should be equals to 9 athletes. And each man can consume 4 slices of pizza, and each woman can consume 2 slices of pizza, plus 3 here, referring now to the coach, should be equals to 27 slices all in all, because there are 5 leftovers of the total 32 pieces. Remember, class, that one pizza has 8 slices and they ordered 4 pizzas, so 8 times 4 is 32. So here you have two equations, your x plus y equals 9 and 4x plus 2y plus 3 equals to 27. So we are going to carry out the plan, and we are going now to substitute, okay, the first equation to the second equations. But first, you are going to isolate the variable x in terms of y. Then we need to substitute this into the second equation. So instead of putting here the x, we need to use now 9 minus y so that we are solving for the variable y. So 4 times the quantity 9 minus y plus 2y plus 3 equals to 27. Then 4 times 9 is 36. 4 times negative y is 4y plus 2y plus 3 equals to 27. Combine similar terms. Negative 4y plus 2y is negative 2y. 36 plus 3 is 39. Okay, so still equals to 27. Then, if I'm going to transpose negative 2y to the other side, likewise 27 on the left side, so they will be changing the sign. So 39 minus 27 is equals to 2y, then 39 minus 27 is 12, equals to 2y. Divide both sides by 2, then 12 divided by 2 is 6, and 2y divided by y, 2y divided by 2 is y. So here, y is equals to 6, referring class to the number of women. So if there are 6 women, how many are male or men? So definitely, we can use our first equation. Then we substitute that y is equals to 6, therefore x is equals to 3, referring to the number of men. So which is the same class. So there are 3 men and there are 6 women. So, it's up to you, class, on how you are going to choose your um, strategy in solving problems, but we can always have the same result. So to check your answer, because we have to test the two equations, class, in terms of the value of your x and y. So remember that your x is 3, your y is 6. So 3 plus 6 is equals to 9, then 9 is equals to 9. If you substitute this also in the second equation, that x is 3 and y is 6, then 4 times 3 is 12. 2 times 6 is 12 also, plus 3. Then 24 plus 3 is 27. So 27 equals to 27. And that would be our solution, class. Now, another example here is a word problem. So this is a number problem, class. If 24 is added to a number, so we do not know that number, but we add 24, it will be 3 times as large as it was originally. Find the number. So when you understand the problem, class, it says that find a number n, or it could be letter x, letter y. So you just let that to be any variable, so that added to 24 becomes 3 times as large as the original number n. Then if you're going to devise this plan, you can use algebraic solution for this one, because this is more apt to use rather than trial and error. Then we just denote, class, from a word statement into a mathematical statement. So a number, well, that is your n, added, that is plus 24. The word becomes is the same as equals. 3 times is 3 times as large as the original number. So we translate this statement class into a mathematical symbols. And we are going now to represent this. So you notice already, class, that we have our working equation. So n plus 24 is equals to 3 times n is 3n. Then we can solve for our n. So n here will be transposed to the other side, becomes negative n, and 24 equals to 3n minus n is the same as 24 equals to 2n. Then divide both sides by 2, so n is equals to 12. Then what is again your n? So your n is actually your number that we are looking. So if n is 12, then we can substitute this class to the original equations that we created. So n is 12, so 12 plus 24 is equals to 3n, which is now 36. So 12, when you add 12 by 24, the result is 3 times the original number 12, which is correct. So therefore, the number class is 12. Okay, so that's how we solve class using the Polyase for processes. Another one is this one. So a student teacher wants to divide his 6th grade class into groups to work on a project. He'd like to have somewhere between 3 and 6 students in each group. So he can have 4 members per group or 5 members per group, and wants every group to have the same number of students. Find the group sizes that will accommodate a class of 36. Okay, so understand the problem. So each group must contain members between 3 and 6 students. So the phrase class between 3 and 6 means that each group must only have either 4 or 5 members per group, because the word is between class. So when we say between 3 and 6, so what is the number greater than 3 but less than 6? So this is what it means by the word between. Okay, it does not say, class, that grouping from 3 to 6. So 3 and 6 are not part of the solution, so each group must have the same number of students to it. So what will be our plan here to solve the problem? So we can use the trial and error by, of course, dividing 36 into 4 or to 5. So we carry out the plan. So if I'm going to divide 36 by 4, because there will be 4 members per group, then I will be having 9 groups. If I'm going to divide 36 by 5, because I want 5 members per group, I will be having 7.2 groups. This is not possible because there is no such thing class as 0.2 of a group. Okay, so in other words, I will be having 7 groups, but there is only one group that has only one member. Kawawa naman siya, class. So this will not be possible. So the only solution that we have is 4. Okay, so trial and error checking is itself, as I said, a solution to itself. So therefore, the student teacher can only have 9 groups with 4 members each. Okay, so that's how we solve class problems similar to this one. Okay, so this one here, okay, it's quite a long one, but it's up to you, class, on how you're going to solve for this one. So as I said, you have your own strategies. So when a retired police officer passes away, he leaves 7 million to his children to be divided among his 2 children and 3 grandchildren. This will specify that each child is to get twice as much as each grandchild. How much does each get? So this statement, class, is very specific siya, class. Okay? Specify according to the siguro ano to, yung last will and testament niya, class, that you have to understand first the problem. So how many children and grandchildren all are all. So we can have here the first child, the second child, the first grandchild, second grandchild, third grandchild. So there will be 5 totals. And the 7 million will be given to this, okay, recipient. So the ratio of the share is that accordingly, okay, the child is getting twice as much as each grandchild. So the amount of one child is the same as the amount of two grandchildren. If the grandchild is receiving 500,000, then 500,000 times 2 is 1 million. That would be the amount that the child will receive. From this statement that the child is to get twice as much as each grandchild. So what will be our plan here? So you can use arithmetic solution for this one. Okay, you can also use trial and error. So here I will be using arithmetic solution. I will be using C sub 1 equals to C sub 2, which is the child. GC1, GC2, GC3 is referring now to the grandchild. And I know that one child is equivalent to two grandchild. Then I can have this one here. Then we can carry out our plan. So if I'm going to add, because there are only 5 persons who are receiving the 7 million class, so the two children plus the 3 grandchildren, the total should be 7 million. But accordingly, each child will receive twice as much as the grandchild. So I can have now the child can be having 2 grandchild equivalent. Okay, so we are just changing our C sub 1 and C sub 2 into the grandchild, so that the first grandchild, second grandchild, third grandchild will simply be your grandchild here. And if you're going now to substitute here, the child, should I say, will be receiving 2 grandchilds equivalent, another child, 2 grandchild, and the remaining 3 grandchilds will be having our GC here. So this will be our not manipulating class, but our um, formula here, or our equations rather. So 2GC plus 2GC plus GC plus GC plus GC equals to 7 million. So if we're going now to add all of this, okay, then what we have is simply 7GC equals to 7 million. Then divide both sides by 7, then GC is equals to 1 million. This means that each grandchild class will receive 1 million. However, because the child is receiving twice as much as the grandchild, therefore the child will be equals to 2GC, so that the child will be 2 times 1 million is equals to 2 million. So thus, each child receives 2 million, while each grandchild receives 1 million. Okay. So if you're going now to test or to check our answer, so each child will receive 2 million, each grandchild will receive a million, should be equals to 7 million. So 2 million plus 2 million plus 1 million plus 1 million plus 1 million is equals to 7 million. So we were able now to check that our solution is correct. Thus, each child receives 2 million and each grandchild receives 1 million. Okay, so again, thank you class for your time, and you can review these presentations again class. So see you next time. See you for our next lesson. Goodbye class.